The first presentation is going to be from Markus. Markus likes to give presentations, he likes to joke, but he doesn't do that often. So let's give a big applause to cheer him up a little bit.
Hello. So,
but before we start, just want to say one thing, because it's a little bit special situation because we have a speaker and assistant. So please also give a big applause to Katie.
Okay. So, is there audio? Yeah. Okay. Good. No, because it's weird for me. Okay. So we are starting late. That's fine for me. I'm past my peak caffeination, so there might be side effects. So I'm not perfectly calibrated right now. So yes, I'm Markus. I've done Ruby for a long time. I started my career with Ruby. I sort of, to my own self-definition, outgrew Ruby a bit. I was actually here the last time when I professionally spoke. It was 7 years ago, also here at the same venue, the same stage. I'm just curious if there's anyone in the audience who might have been there. Wow, okay, I feel at home, thank you. And also I did a mutant workshop earlier, and there I saw some faces who also were at the mutant workshop. So if you could give me more warm feelings in telling me if you were at the mutant workshop. Yeah, perfect, so anxiety soft. Okay, so I built this mutant thing. This is not a mutant talk. This is a talk I've given multiple times, despite saying I'm not a professional speaker, because I typically give it on napkins. It's like I'm sitting together with some people who might enlist my services, and we talk and talk and talk, and I start to scribble things and make up ad hoc mental models, ad hoc analogies to convince people to do things like I want them to do. And over the years, I've refined some of these, and this is a level of refinement I've never actually presented to anyone, so you're all basically guinea pigs. Yep, okay, so let's move on a bit. These slides are not from a UI engineer. I'm a backend dude. I typically do not even work formally in backend anymore. I do more technical leadership stuff, do the first of a kind, and then help lots of people to replicate the patterns I make. But my typical title in these bigger organizations is as a VP of engineering or principal engineer. But I still do unusually high amounts of hands-on stuff. So, and this is a story about that. And this is how I looked 7 years ago. And at that point, we even had Wi-Fi. There's a Wi-Fi password on the, or at least a sliver of the Wi-Fi password, still visiting. Yeah, so when I say I've been busy, what happened is that I moved to a different country, I took on different kinds of clients, and that had an interesting upward trajectory, at least economically, so I more or less left all open source efforts behind. In the end, it turned out that what I still had in the open source was too useful to let it die, but I needed to convince myself to still spend time with it. That is this mutant thing. So mutant was converted to a commercial tool, so I have a little bit of incentive to keep it going. Yep, and this is basically the slide I should have put up for the last 20 seconds. So let's. What happened to me is that in the end, I had to discover that for the kinds of software I wanted to write, Ruby wasn't the main thing to go with. And the learnings I had actually also apply back to Ruby. So that's the reason I'm giving this talk. This talk is not a very technical talk, but it helped me a lot in technical decision making. So let's see where this goes. Yep, so I've seen lots of interesting things. Again, I'm too late to put up that slide, so I'm going to skip it because the interesting thing is that learning. When I say discipline doesn't scale, it doesn't mean that discipline doesn't matter. It means that if you have an organization of any size and you have designed processes around, okay, so we know, everybody in this room knows we have to do things in a certain way, we have to restart a certain cluster in a certain way, but it's just all in our heads. Or we have to do a database migration in a certain way. Or we have to roll out features in a certain way. Or we have to remember that we have to update also the mobile app when we ship schemas change. This is what I say with discipline. It's really great that we notice it at a time, but the discipline scaling at any scale, at any org. If you have 3 people, even 3 people will screw up. If you have 5,000 people, 5,000 people will screw up at a grander scale. So the only thing that actually helps at scale is automation. But this is not a new message. So we all have heard it a lot. But what helped me a lot is convincing people to spend the right kind of automation with a specific mental model. And this mental model is what I'm trying to convey here. So that's the last static slide, and now we are starting with what I typically scribble on napkins. So I'm so proud of 3 vertical lines. Yeah, now it's time for my assistant, because we are going to demonstrate throwing stuff at a dartboard and seeing what sticks. You could also say we are throwing shit against the wall and see what sticks, but I was told that this audience might be fine with that statement. So my assistant needs to throw a dart now. So we threw one, and it fell in the red area. And I'm going to explain all of these areas, but let's throw a few more. Another red one. We had a green one. Okay, let's throw more. I need some gray ones. I need some. Perfect. Let's give it a little bit more spamming, Katie. Perfect. So what does this actually mean? So this is the mental model of a contribution threshold. The very left vertical bar. Katie, can you stop? Thank you. I do not want to read the distribution right now. Okay. So these things also have labels, and I'm going to go relatively abovely on these. So my mental model over the years has formed that there are 3 different thresholds in every software system. There is the ecosystem threshold. The ecosystem threshold is defined by what your base language comes with batteries included. So if you go with a very sophisticated type system like Haskell and you use it, you have a very high ecosystem threshold because it will literally not compile. If you go for C, you have like, okay, so the GCC did produce a binary. If you go for assembly, like, yeah, your assembler could read it. So this is the ecosystem threshold. And this is the baseline. So everything over time degenerates to the ecosystem threshold unless you put in work. Then there's the automation threshold. The automation threshold is all the tools you put on top. This includes tests. So if you put in a linter, if you put in, let's go Ruby specific, you go with TDD, you go with DDD. But this is everything what you spend on building on your process to go to an automated quality gate, which typically then ends with the CI. The CI can be almost non-existent, and still today I get called into Ruby or Python or whatever kind of code base, and I still find that many of these processes are only gated by a minimal increase over the ecosystem threshold. So you have absolutely minimum automated quality gates. And then there is a contribution threshold, and this is my mental model about every contribution you throw at the wall passes one of these thresholds, or even none of these thresholds. So if we go for this very light gray dot left to the ecosystem thing, that's something you tried to contribute, but it didn't. And for Ruby, you had a syntax error, or it didn't boot, or something very, very basic. Then you have the green ones, which actually fall above the contribution threshold. And the contribution threshold basically signifies, if I merge this, do I help the company I wrote this piece of code for? And one of my core tenets is that there's always a gap between the automation and contribution threshold, and this is where discipline goes. So everybody here in the room should have had the experience where you have something green on CI, you press the merge button, and shit happens in production. And this is then the red area. And this red area is the most dangerous area I've identified in software engineering for my mental model. And it's way more visible if you oversee thousands of devs. But if you are in a very small organization with 3 developers, you can say, doesn't apply to us. We always have the discipline, but you maybe haven't thrown enough darts to see the distribution. And now I need more darts, Katie. Now let's put in way more darts. Let's put in, you can hold the trigger down if you want to. Yeah. So as you see, this is a very special distribution because this is a Gaussian normal distribution, and I tweaked it a bit to fit the slide and stuff. So it's not, don't hold me hostage to the mathematics here. And in the end, the main goal for us is that we only ever want to put these green dots into production, but also we want to minimize the time we spend with the red dots, and we want to maximize the time where we put in a cycle. So we notice, okay, so a spec fails, some linter fails, CI fails. That's easy. We can just throw the darts again. And I'm going into why this matters for LLMs even more in a few moments. So let's go and actually accept the fact that this is the contribution distribution. And now there is an interesting problem with all developers, and I'm the perfect example for overconfidence, that I think my contributions are always there. So, and this is typically not the case because I also have very bad moments. And this is then when I had not enough sleep, had a fight with my wife, whatever. And if I integrate all of these over time, it basically looks back to this. So the fallacy to say that my team is special or our team is special, I've seen this in all sizes. So I've seen this in, like, in the end, if you do this for long enough, you always end up back with that curve. And yep, so that's now the problem with the LLMs, and you can press P if you want to, Katie. LLMs get us way more throws of the darts. And my mental model at that point has been to work very, very hard to move these thresholds. And I hope this thing moves. No, it doesn't. It actually moves. So if you can invest more into the automation threshold and lower the amount of discipline you have to spend, then you can actually increase the chance that the automatically rejected dots, you just spin the dice again, you say the LLM this is wrong, you put your, or you say your humans, hey, there is a CI failure, please fix it. And which then maximizes the chance that you actually end up in the green area. And now let's go to the Ruby specific part. In Ruby, we have a problem. This is the reality of Ruby as I have experienced it at large scale. The ecosystem threshold is very, very low. The only thing Ruby battery included is it parses and eventually it boots. That's the only thing which comes battery included. So any kind of tooling, and this is also why the Ruby ecosystem has developed more tooling. So the Ruby ecosystem has spearheaded TDD and so on. But the tooling is significantly more important. This gap, which I said the machine enforced gap, is so much more important in Ruby than in all other language I have experienced over the last 7 years. And more or less, this already concludes my talk. Thank you. Yep, so this is then more words, but since we lost so much time, I'm going to take this very short. I would really love to hear what the room has to say. It's very silent. This is good or a bad sign. There are lots of ways to improve the tooling threshold in Ruby. So we all have heard about tools like Mutant, we have heard Sorbet, we have heard RBS. There are so many ways we can do this, but this is all extra. This is not batteries included. We have to work really hard to increase the automation threshold because the LLMs will simply throw more darts and they have absolutely no idea where they landed. It's all stochastics. That's the message. Okay, and I'm curious if I could get some questions on this mental model. It's interesting, if nobody asks questions, I assume that everybody knows it better than me, and I will ask questions to people, but...
Can you go back to the last slide?
Which one?
Just one back.
One back. This one?
There's the... keep going.
The overconfidence one, or the...
No, the one about the LLMs ask you to spend 10 times more.
The LLMs ask you to spend 10 times more, yes, because if... That one? That one? You see more about the slides than me, so...
No, the one before that.
The one before that. Bob. Yep, ask you to...
Yes, can you talk about this one?
Yes, exactly. So if you throw more darts, you have more darts falling into the red area simply by statistics. So we can throw many, many more darts at the wall right now, and we will have more commits that actually pass CI now. And we are literally, as we are now being asked, like, why can't we merge this by all stakeholders? And the idea is that we have to work very hard to reject more of these and moving the automation threshold higher, closer to the green area. We will never be able to eliminate that. If we are able to eliminate, my understanding at least of the current space is, if we can eliminate the red area, then we are at AGI and everybody's out of a job. That's my current understanding. Sure. Go ahead.
So my question is, what do you define by shit on production? Because it might be a bug, which is the most important problem for us, for devs, but it's not necessarily
anything that reduces, that doesn't contribute to the value of the software stack. So if you ship a small bug, that might be okay, because you temporarily reduce the amount of contact you can, or its contact form. But if you screw up a text lot system, that could have lasting confidence, long-lasting if anything, so I do not want to just say bug. Bug is such an overloaded term. I
Exactly.
typically try to say like, if you ship the wrong database schema now and it's discovered in 5 years, that is a very long-lasting damage effect.
Correct. But my feeling is that these are the easy bugs, so to speak, because this the AI can actually test it, find it out, and so on and so forth. I think
But
the
it can't
problem
eliminate the red area where we actually have to verify that we do not create long-lasting damage.
you can't, but you use the argument of scaling. Like if you have 3 guys, the problem is of this size. If you have 500 guys,
I
then
think it's the same problem. It's just that the 3 guys experience it differently because they do not have enough.
I agree
cycles.
with you, and I agree that these bugs will be on production. The problem is that I think there are even more, so to speak, bugs or let's say misfunctions of the products generated by AI, which is like the functionality that no one asked for, and the products become.
I think it's not more or less. It's just that in some we throw more darts now, so more goes out, and we have limited time to work on this red area to reject things. And for that reason, more bugs are hitting. It's not because the LLM is specifically bad. It's just as bad as any regular developer. But because there's such a high volume now that we haven't narrowed this gap between the automation threshold and the contribution threshold, that's the reason more bugs go out.
Yeah, I'm with you totally. I think there are like 2 problems we will have. One is the technical problems with this so-called bugs, the damages of the databases, and so on and so forth. But with this 10x, we have also the problems of diminishing products quality because of the things which are shipped, which are not a very good value for the users.
Exactly, because this was from the perspective of the developer. The product people have the same. They do not refine their product anymore as they used to be. It looks
Correct.
good enough.
Yeah. So I think the challenge is actually to bring the product people closer to the devs.
I strictly talk here from developer perspective.
Yeah,
So,
understood.
yeah.
Thank you.
Please go ahead. The language itself then goes into the ecosystem threshold. So the better the base language is, the less you have to work on the automation. So you still have to work on the automation all the time, but bridging from no type system and it boots or it parses to a good quality contribution threshold is much, much harder work than coming from something like with a strong type system. I'm not saying it's futile. I'm just saying please be aware about it. There is the standard library is very, very important. The defaults in the ecosystem matter a lot. So the statistically everything regresses to the default at scale. So if you have an ecosystem that cares or an ecosystem that doesn't care. So in Ruby, I most of the time in large scale RAID systems, I have to fight random monkey patches from third-party libraries leaking into the core. So and this is a property of the language that enables that kind of behavior, which is then even more lowers the ecosystem enforced threshold because in more sane languages, sorry to say so to Ruby group, you can't do that kinds of global damage. So Ruby has rolled back a lot. So before, if a certain third-party library 30 minutes in production requires mass n and then redefines the division operator, that kind of stuff is solved, but it's still possible. And if it's still possible, low likeliness times time equals guarantee to my experience. So that's the kind of hard learnings I had. So if you have 1,000 Ruby servers and 20 deploys a day, there's almost a guarantee that these things will go into weird stages. And then you fight against the ecosystem more. It's the ecosystem threshold more. You want to work on the automation, but you're being held back by the ecosystem. So there are things we can do in Ruby. We can freeze the core classes, and I always do this in my Ruby projects. I force all my production systems to be fully booted, then I patch out evil, I patch out method missing, I patch out lots of stuff to harden this thing. But I shouldn't have to do this, or I would love to just have a big Ruby VM method where I can nail it down. It was discussed multiple times on the issue tracker. Point here is I do not want to discourage using Ruby. It produces economic value, but I want people to be aware that there's a much bigger gap to bridge, and this gap is becoming more important. Not because the LLMs are so good, but the LLMs, to my experience, are just an amplifier of existing patterns, and we have limited time to review the red area, so more stuff goes out. So we need to reduce the size of the red area so we can catch up. Please go.
In terms of implementing
Exactly. Yes. Mutation testing to actually reduce the wiggle room. Sorry to say so. As a, I types, you can go through the pain of adding Sorbit or RBS to a bigger code base, and it helps at scale. Else Shopify wouldn't have done this. I've also seen it being retrofitted in production and with good effects. There is property tests. There is not really a good library I know about in Ruby. This is an open field, so if anybody wants to write a property testing framework and make it popular in Ruby, I would be very happy. Property testing basically goes against invariance. So you define invariant like, if I reverse a list, it's always the same length. And then then this property gets seen by a tool, and it generates lots of random lists, and then maybe it generates 1,000 random lists and checks this property against that. And you can make very, very advanced properties like the sum of all the line items can never be smaller than the value of one of the line items. All of these kinds of properties, and it would, in the property testing tools, then try to find input counterexamples where you violate that. It's also a stochastic process, but it's a phenomenal way to test business logic. You basic. No, it's always randomly generated, so you can then decide, like, today I run my CI for 2 hours and find counterexamples. Each time you find a counterexample, you basically have a bug. And this kind of tools is very, very often used in Haskell. So in Haskell and finance, it was absolutely a God's end to use it. I only think in ratios. So the ratios between red and green dots is the important thing. Like the absolute thing, if you have a small team, you have less darts. If you have a big team, you have more darts. It's all about the ratio. How much? So the thing is, like, if the green dots have a very small area, then you have more time to actually work on the product. So it's in my opinion, the ratio, not the absolute value. Please go ahead. Right now, so if I had no economic constraints, right now I would always work in Haskell, but Haskell is a very hard sell. So if I talk to a random VC and want to do something, or people recruit me, hey Markus, we have a greenfield, let's do it. I stopped arguing for Haskell, because if I argue for Haskell, I have to spend 80% of my time arguing for Haskell and spend 20% of the time working. So right now it's always Rust, because it's an easy sell and it's an 80% Haskell to my experience. So.
So in your experience, what is the point on your graph where you should stop investing time and money into the automations and start investing time into the cultural stuff?
So I think that culture doesn't scale. So this is culture is just a form, it's just an encoding of discipline. So lots of companies are absolutely obsessed about their culture and absolutely misinformed about their culture. Culture is, in my opinion, a second-order effect. So you can celebrate your culture when it's good, but if it's bad, it's most of the time more critical to fix the deterministic part, which is the automation threshold, and the culture comes next. So in just saying, oh, we are going to review better, oh, we are going to have a better post-mortem process, and then we write action items nobody ever gets to, that works really well in a slide deck about our culture, but it doesn't really move the needle. That's my personal experience. So I obviously have lots of people disagreeing with me on that.
Right. So we are out of time. Thank you very much, Markus.